Evolution, one of the key biological processes that shapes all forms of life that we see around us today. A process which I'm sure you've been taught in school, likely through Charles Darwin's proposal of evolution through natural selection, whereby individuals with an advantageous trait are able to survive and reproduce, passing on this beneficial trait to their offspring. One example of this is giraffes with longer necks being able to reach the more abundant leaves on the tops of trees, outcompeting their smaller necked counterparts. Darwin's finches on the Galapagos Islands are also a good example. They had selection act on their beak size for generations until eventually speciation occurred, meaning new species of finch were formed with specialised beaks that corresponded to the type of food they ate. But today I want to talk to you about the evolutionary processes that we may not know as much about. The example I shall be discussing today is the evolution of flightlessness in birds, which was until recently thought to be rare. This significant evolutionary process is thought to have been biased by anthropogenic, meaning human, impacts, such as non-random extinction. And these ideas were brought forth in this paper here, which I shall be discussing today. So let's get started. This paper poses the idea that human impacts upon flightless bird populations are the reason why flightlessness appears to be a much rarer trait than it actually was. But how on earth did it determine this? Well, the researchers compiled a list of 581 bird extinctions from the late Pleistocene 126,000 years ago by using fossil records as well as historical literature. From this list, they determined that 29% of extinct bird species were considered flightless based on their morphological characteristics, which are the physical attributes that the individuals had. Some examples of extinct birds that were flightless include the dodo, the moa, and perhaps the largest flightless bird to ever exist, the elephant bird from Madagascar. But let's put this list into perspective. Based on living flightless bird species today, we believe the total number of flightless species lies at 60. But when we include the findings of this list, the total number of known flightless bird species increases from the currently thought 60 to 226. This means that the evolution of flightlessness in birds was 4 times more common than what scientists currently think based on living flightless individuals. So what does this increased evolution of flightlessness tell us? Well, to put it simply, it tells us that humans had a significant impact upon flightless bird populations, which shows us something known as a selective pressure. A selective pressure is when a certain characteristic or trait an individual has is either favourable or unfavourable in the environment it lives in. In this case, humans place a selective pressure upon flightless birds. But why? Well, to begin with, flightless birds are much easier to hunt than flighted ones. They also would have been more abundant, as flightless birds are thought to have evolved in response to the extinction or absence of mammals. Unfortunately, this also made them more susceptible to the introduction of non-native mammal species by humans, such as rats and cats, which would predate them. All of these factors made flightless birds very vulnerable to human impacts. Well, to begin with, there may have been some sampling bias, due to the fact that we do not have a fully completed fossil record for all of the bird species which have gone extinct. On top of this, all of the extinct flightless bird species were assumed to have gone extinct ultimately due to human impacts, but this may not have been the case. There may have been other reasons behind their extinction, such as climatic changes and the species just not being physically able to adapt to these newer climates. It is likely that some now extinct flightless bird species provided ecological functions that are unlikely to be fulfilled, such as New Zealand moas grazing on trees and shrubs, much like goats do across the rest of the world today. It is also likely that these losses are underestimated due to the fact that many species go extinct without leaving the fossil record at all. Impacts on future evolutionary research are that we now know we must acknowledge human-driven impacts upon certain species when determining their evolutionary history, as these human impacts can distort them by making some species more susceptible to extinction.